Hello again and welcome back. This video will just pick up where we left off last time. I am going to draw a line because this is a completely new skill. I'm going to show you today how to do a prime factorization. So let's call this section prime factorization. And this is about breaking down. If you recall in the video we just did, let me write this and then in this video clip we were building up. With factoring you are breaking down. So we're sort of going the opposite way. I want to start with, I've shown you a glimpse of this already, but I want to start with the number 20. We're going to factor the number 20. We're going to break it down completely. So let's start with, before when we listed the factors we started with 1 and 20, but this time I want to use something other than the 1. So I'm going to use the 4 and the 5. So 4 times 5 is 20. Remember 20 is called the composite. And I'll look at this 4 and 5. I'm actually going to connect those. I'll look at this 4 and 5 and I think, could either of those break down any further? And the 5 itself cannot. 5 is prime. It won't break down any further. But look at this 4. Can you break a 4 down any more? You sure can. You could break it down to 2 times 2. And then both of those numbers are prime, so those won't go any further. So we would say that the prime factorization of 20 is 2 times 2 times 5. And you may be thinking, wait a minute, where's she getting that stuff? Here it is. 2 times 2 times 5. That is the prime factorization of 20. So let me ask you a question. What if I take that composite 20 and instead of using 4 times 5, I use 2 times 10 as my factors, because 2 times 10 is 20. Let's see what happens with this one. I can't break the 2 down, but I can break down the 10. 10 is 2 times 5. Look at that. 2 times 2 times 5. Same prime factors. It doesn't matter which of the factors you start with, you'll get the same prime factorization if you break it down correctly. So I wanted to point out that if you chose the 2 and the 10 and I chose the 4 and the 5, we will get the same answer if we do the math correctly. Okay, let's do another one, or 2 or 3. This is kind of an important thing to be able to do. Let's prime factor, the composite 48. This is your composite, because there are lots of ways to get a 48. You can do 1 times 48, you can do 2 times 24, 3 times 18, 4 times 12, 6 times 8. I'm going to go with 4 times 12. I just like that one. It doesn't matter. So 4 times 12 is 48. But the 4 will break down to 2 and 2. The 12 will break down to 2 and 6. The 6 will break down to 2 and 3. So we would say that the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. You get the lowest ones on there. This is called a factor tree. Let me go ahead and write that in for you. This, with all these lines, is a factor tree. And with a factor tree, you pick the lowest hanging fruit. So you have the 2, the 2. Imagine these are apples. You pick the lowest ones. So the prime factorization of 48 is going to be 2 times 2 times 2 times 2 times 3. If you wanted to write that with exponents, you absolutely could. You would say 2 to the 4th power, because there are 4 of them, times 3. That is an algebraic way to write your prime factorization. All right. Let me go back to this one and let's put the algebraic way. We've got 2 of those 2's, so we could say 2 to the 2nd power, because there are 2 of them, times 5. Okay, let's do a few more of those. I just don't feel ready to turn us loose on that. So let me make a copy of this page. Actually, there's a clean sheet I can bring up. And let's do a few more of those. Let's do the prime factorization of 100. Remember, factorization is just breaking down. In most of mathematics, you're either building up or breaking down. And this is breaking down. Okay, so I'm going to use 100 as my composite. And let's go ahead and write the word composite. Composites can be broken down. And I'm going to use 10 times 10. You could use 5 times 20, 25 times 4, whatever you want to do. Actually, let's do 25 times 4. That's a good one. 25 quarters make $1, or 4 quarters make $1. 25 times 4. 25 will break down to 5 times 5, and 4 will break down to 2 times 2. And then that low-hanging fruit is ready to go. It can't break down anymore. So the prime factorization of 100 is going to be 2 times 2 times 5 times 5. If you want to write that with the algebra way, you would have 2 to the 2nd power times 5 to the 2nd power. Let's factor this 100 using a different set of factors. Let's use the 10 and 10. So for 100, again, that's my composite. We're going to break that down using 10 times 10. 10 would be a product of 5 and 2. 10 would be a product of 5 and 2. And there again, you have that same set of numbers. Let's factor our 100 using 5 times 20. Okay. So 20 will break down. The 5 won't, but this could be 5 and 4. And that would be 2 and 2. So again, you end up with the same set of prime factors. Doesn't matter how you go about it, you will get the same prime factorization for the number if you do it correctly. Okay, let's do one more. My pen is running low, so I'll fit in one more, I hope. Let's use the number 64. So my composite is 64. 64 is a product of 8 times 8. 8 is 2 times 4. The 4's will break down. Be careful here. You got to get them all. You've got this 2, these 2, this one, and this one. So there are 6 of those 2's. 2 times 2 times 2 times 2 times 2 times 2. Or 2 to the 6th power is a short way to write that prime factorization. As always, if you have questions, contact your instructor. He or she will be able to help you with multiples or factors or any of the things we've covered here. I do want to tell you, with respect to the vocabulary, that this is called the composite multiple, and all of these low-hanging fruit, these are the factors. Okay. All right, in the next video we're going to look at this memory piece. So if you don't have this already prepped, you want to do that before the next video clip, and I will take you through the rules of divisibility for each one of these. Okay, so I will see you soon. I hope you have a really good day. Bye-bye.